for y fixed. Okay. Then you simply just calculate its gradient. Even if it's coming up, right? So then you went back to negative numbers. Even that case will still make sense. Right? And even if we have a situation like this, we have this kind of line, okay, and the function is never sorry, and the graph is all the time below, right? And then in that case, what do we have? We're looking at this minus that. Wait, no, that the line minus the function. Then in that case, we are taking supremum of possibility. So every time it will make sense. So and that supremum may be that whatever we are taking the supremum of, that may be unbounded. So it's totally possible that for some y, f star can take infinite value. Okay. We say supremum is infinite. Yeah. So yeah, classically it does not exist. Alright, and so we want to find the supremum of this expression. Then simply what you can do, we can find at whatever point the supremum is attained, it has to be like local. If either it's infinity or if it's like a point of it should be a point of local maximum, right? If it's maximum, it has to be a point of local maximum, right? Or you can argue that we are maximizing an affine function in an interior of a set, because we are maximizing this thing over for all positive x, the bounded one. So I have an open set in which I'm maximizing something. Right? So that an easy way to do this would be calculate all the maximum points, calculate all the critical points. And then what you can do, you evaluate the given function at all the critical points, and whichever gives you the maximum value is one of the maximum. Okay. So all you have to do is just find the gradient of this. So we get d of dx of that expression, y x minus x times log of x. What do you get? Keep y fixed. So that is nothing but that's y minus x times the derivative of log of x, that's 1 or x, and minus log of x times the derivative of x, that's just log of x. Alright? So set that equal to 0 and you solve for x. Correct? What do you get? And we get that you get y minus 1 is equal to minus log x, therefore we get log of x is equal to 1 minus y, which is giving us that the x has to be exponential of 1 minus y. Correct? Did you do the calculation right? That's 1. So you get 1 minus y. It's y minus 1, right? Remove that log that side. So it's y minus 1. And it's e to the power. Right? This is saying that we only have one critical point. Correct? Then what you can do, then you may find the second derivative. Right? Then if you find the second derivative, what do you get? This one will be 0 because it's constant with respect to x. X over x is just constant, that's 1. And what do you get? Derivative of this. So we get minus derivative of log of x, which is just 1 over x, right? So eventually, what do you have? So the d by d squared. Yx minus x ln x is minus 1 over x. What is that? Positive? Correct? Oh, it's negative. So local minimum, local maximum point where your second derivative is negative is the point of local maximum point. That's our calculus thing, but we now know a little bit of convexity. We know that if the second derivative is negative, that means the function is concave, so it's open downwards, right? So that's everything in calculus comes from the convexity. Second derivative is negative. Why is that? It gives you the second derivative gives you local maximum, because the second derivative is negative tells you the function is concave down. Because I think this is from that the second derivative is positive and the function is concave. Here it is negative and the function is concave. If it's a positive function is concave, so negative function is concave, right? So that's why in calculus we do that. At that point, if the second derivative is negative, that is a point of local maximum, right? So that's why, because if the second derivative is negative, that means the function is concave down. That's why it's a point of local maximum. Right? So therefore, for this value of x, this expression is taking a local maximum, right? But that local maximum has to be the global maximum because there is no other critical point. Make sense? Because if there was some other local maximum, then you have to go down, come upward. So when you go down, come upward, there will be a local minimum somewhere around there. And some other local maximum, you have to find some critical point, but you're not finding, right? Or you can simply say that the second derivative, this is minus 1 over x, is always negative, so its function is always concave down. So it's always concave down, so whatever critical point you get is your local global maximum. So we get global maximum. So we get that x is equal to e to the power of y minus 1 gives global maximum. Correct? Global maximum of what? This expression. Yeah. All the points in the domain. The domain is everything, all the x's are positive. So they're both basically both the same thing. Boundary point will not make sense here because your function is not defined at the boundary. Basically, this is showing that the function is convex or concave down. So whatever value, extreme value you can take at the boundary, it will be like really very small. And you can see what's happening at x. What happens as x goes to 0? You know the limit as x goes to 0. I think that is 0. You can put L'Hopital's rule and show that as limit x goes to 0. So the thing as x goes to 0, log of x goes to minus infinity. But x goes closer much faster than log x goes to minus infinity. Right? Right. So at boundary, it is, you can sort of say that this is kind of defined, but it's taking smaller value than this particular value. I need more page. Oh, I believe. Right. So what we have found, we're basically finding f star of this and saying that f star is compound by for each fixed x, y, we have to find the supreme of that. And we have just calculated that the supreme of this expression for each fixed y is attained at x equal to e to the power y minus 1. So basically what we have to do, if we want to find f star y, we have to just plug in x equal to this in the So therefore, what do we have? That f star y, which is equal to the supremum of over all x in the domain y x minus fx. That's nothing but y times e to the power y minus 1 minus x times log of x, but x is e to the power y minus 1 times log of e to the power y minus 1. So everything will work out as this is just y times e to the power y minus 1 minus e to the power y minus 1, and that's nothing but y minus 1. Correct? So we have this e to the y to the e to the power y minus 1, and you have this minus y e to the y minus 1. They will cancel each other. You basically have minus of minus. Correct? So that's so there. That's our f star y for this particular round. Okay? Another example. Little bit general. So if f wait. No. That's what we are doing all the time, right? So we are saying this supremum is